So, welcome back. Today is experiment number 2. We're going to go over mass, volume, and density measurements, as well as how to use significant figures. Now, the significant figures we're going to leave up to your instructors to further clarify, but in this instructional video, we're going to show you how to measure the masses of samples, such as this aluminum rod. Volume, I would turn on this faucet, but we're in a drought, so we're not going to go ahead and do that. And we'll show you how to use different types of equipment, such as balances and the different volume measurement and dispensement tools. So let's go ahead and look at the top load and balance. So the first instrument we're going to look at today is the top loading balance, as seen and sold on TV. Now, the top loading balance is going to be used to measure anything that is from 0.01 grams all the way up to 400 grams, but it's mostly going to be suited for something that's a little heavier, that is at least 1 or 2 grams. And this way we can minimize the error associated with the measurement. Now, this model right here is the Galaxy 400, and we will be using this for certain measurements in this experiment. Now, to use this thing properly, what we need to do is first we need to make sure that the instrument is turned on. So we'll go over here, we'll press the on button. You'll see the digital display light up, and then it should flash 0.00 grams. Now, if it doesn't flash that and the number is off by some amount, what we need to do is press re-zero. And what that will do is that it will correct the digital display to a 0 or negligible amount, where we can make sure that we're having a very accurate measurement. Now, once it's actually zeroed, the measurement itself is going to be very easy. All we'll have to do is take the thing that we're going to be measuring and place it directly on the instrument. Now, these balances right here are very delicate, so whenever we put something on the instrument, we have to be very careful with it. Now, I've placed an aluminum rod on top of this balance, and you'll see the display now reads at 13.85 grams. So when you write this down and you're collecting your data, you're going to write down 2 things. Number 1, you're going to write down the make and model number. So in this case, it's the Galaxy 400. And of course, you'll write the measurement itself down, which is 13.85. All right, that is if you are measuring a solid sample that cannot possibly react with the surface. Now, if you are measuring out a powder sample, a solid powder sample, you can measure it out in one of 2 ways. The first way is to go ahead and set a container that you're going to pour your sample on. So in this case, I'm using a watch glass, and although you may not be able to see it that clearly, this is a piece of glass that we can go ahead and put things on. Now, we'll set this on our scale, or our balance, and then we'll go ahead and hit the re-zero button. And what that'll do is that'll subtract the mass of that watch glass for us, and then anything that we add onto it will be the mass of our sample itself. So that is way number 1. The other method that you can do is we'll set this back to 0. We can take something that we're going to measure it in. In this case, I'm going to use our weighing dish, this little plastic piece of container, and we'll put this onto our balance, and then we'll record the number here. Now, once we add our sample in, we can then subtract the value that we've recorded in order to measure our mass. So those are the 2 ways we're going to do it. Now, if we had to do measurements where we're going to be adding more and more mass to it, you would do it by this method, where you weigh out the initial container first, and then you'll weigh out every single additional mass increment. If it's just one time, then you'll go ahead and zero the container first and then take that mass measurement. So the next instrument that we're going to look at is the Mettler AE100, as seen and sold on TV. Now, what the Mettler AE100 is actually an analytical balance. The analytical balance is used for measuring anything that is very light, so less than 1 gram, all the way up to 100 grams. Now, these things are very sensitive, and we never want to max out over 100 grams. To use this instrument, it is much the same as the top loading balance, except some of the features are slightly different. Now, there, of course, is an on and off button, just like in the top loading balance, but the re-zero button isn't located on the on, it is located on the left-hand side. So when we need to re-zero something, we'll just press this on the left. Now, as the analytical balances are used for things that are much more sensitive, and we have a lot more accuracy and precision with these, what we're going to have to make sure is that there's no air currents whatsoever that are touching our sample. Now, the way we ensure this is to make sure that these windows that I'm currently opening right now are closed. So whenever we put our sample in there, say if we are measuring this Erlenmeyer flask with this rubber stopper, once we place that on there, we're going to close all these windows. And the reason why is that, as you'll notice, that the numbers will fluctuate a little bit as we're measuring it if there's any air current above it. So even the simple fact of me talking over it can change the measurement. So we want to make sure all three of these windows are closed when we take the measurement. Now, when we take our measurement, we're going to make sure we write two things down. Again, we're going to make sure that we write down the make and model number, so Mettler AE100, as well as every single number that is given by this instrument, by the digital display. So you're going to write 48.3413. Even if the last digits are zeros, we're still going to write those out. Now, in this experiment, you're going to be measuring the volumes of your liquids as well as the masses of your liquids. So there's an unknown section. Now, to do that, what we're going to do is use this volumetric pipette. Now, what we need to do is fill it up to a line right here, and you'll see the actual picture. Now, the other thing that you need to be careful of is not to overfill. Now, people tend to make the mistake of filling out to the big red dashed portion. That is a mistake that we don't want to do. So, when we're doing our unknown, the first thing that we're going to do is we're going to measure out our Erlenmeyer flask with our stopper on it. We're going to write down every single number of it once we have all the windows closed. Then we're going to take it out. We're going to add 10 milliliters by using this transfer pipette. And the way we do that is if we have a liquid, here I have some deionized water, I'm going to insert my pipette all the way into the water. I'm going to squeeze this bulb with my offhand, place it over the top, and then let the suction bring the liquid up, all the way to the lower mark on our pipette. And then once that is there, I'm going to go ahead and transfer it into my Erlenmeyer flask. And once it is fully transferred, I'm just going to let gravity do its thing here. So it takes a while, a little bit of patience. Let it drain out. Now I'm going to not tap it on the side. You'll notice there's a little liquid left. That is okay. They're designed for that. Then we will go ahead and re-stopper our flask. We'll place it back in there. We'll close the window. And then we'll take down the measurement that is on our balance. Once we've done that, we'll do this 2 more times, and then you'll simply subtract the differences to get the individual mass measurements for each measurement that you're doing. And if you have any questions, you can always ask your instructor. So I hope this instructional video will help you out during your lab. If you have any other questions, you can contact your instructor either by email or just wait till lab to try to figure things out. They will go over it in further detail. For now, this wraps up experiment number 2, and we'll see you next time.